Okay. All right, guys. So here's the cool thing. We're going to start a new unit today that has nothing to do with what we were doing in the first semester. And a lot of people really like it because it's different. It's nothing to do with graphing. We're looking at exponents. So let's talk about background knowledge of exponents. It is part of PEMDAS, right? Exponents. It's the E in PEMDAS. It's parentheses, then exponents. So it's pretty high on the list. But if you look at this first page of your notes packet, you see 6.1 is broken down into 4 parts. We're going to cover these 2 parts today, and then these 2 parts tomorrow. All right. So our goal is to get through step 1 and 2. And when I say steps, they're not really steps. They're rules for adding and multiplying exponents. Okay. So let's go ahead and go to page 1. All right. So you guys have seen this before. I really need you guys to make sure your calculators are out, your headphones are out or put away, and your phones are not on, on your desk and you're not on your phone. Because this is something new, and I want to make sure we all start off at a good way this semester. Finish the year strong. It's just different. It's not hard. It's just different than what we've been doing. Okay. Today's easy. All right. So you guys have seen a number like this where you have a big number and then a little number that's raised. Well, if you don't know already, the big number in the front is your base. That's the number that's multiplied itself the number of times from the exponent. Okay. The little number that's raised is the exponent.
So that's 3 times 3 times 3 times 3.
Yes.
Oh, I know it.
So the exponent, I want you to circle this. It's sometimes referred to as a power. Okay. Circle that power, because I'm going to refer to it as a power a lot this unit. And we will as well, but it's really how many times the base is multiplied to itself. So look down here, just like Tanner just said, 3 times 3 times 3 times 3 is really what this is. We call this expanded form when we write it out. All right, so really what you're doing is you're saying 3 times 3 is 9, times 3 is 27, times 3 is 81. All right, so that's 81. But as with most things in algebra, there's a way you could do it in the calculator that makes it faster and you don't have to do any adding, multiplying, or whatever. Okay, you will simply put it in the calculator, 3. And here's the exponent key. It's right above the division key. It looks like the roof of a house, and I call it the house top. Some math teachers call it a caret key. I know it doesn't look anything like a carrot. I don't know why that ever was started. It is just kind of been that way for a long time. So you may have had a teacher in the past call it the caret key, but I call it house top. So if I ever say 3 house top 4, that means 3 to the 4th power. Okay. So 3 house top 4, that's going to put your numbers, the 4 as an exponent. Is yours doing that too? Everybody, did y'all try that? Okay. So remember, if you're at home and you do not have access to a calculator, you can download the Calculator 84 app. And it's the same as this, what this looks like. Okay. Then press enter and it will give you the answer, 81. Okay, super. So what we're going to do here is we're going to write it out in expanded form first. But then you can just put it in your calculator to see what that is. 4 to the 5th power is 1024, yes. Okay.
Negative 729.
Okay, so, but I want you to make sure, did you put these parentheses in, Tanner?
Wait, what was the full one?
24.
Oh, no. Somebody just forgot to erase what they did in last period.
Okay. All right. So here's the deal. In this unit, when you're using the calculator, if it has parentheses, go ahead and put the parentheses in the calculator. For this today, it's not going to matter. You could see that if you did a regular -9 to the third power, it would get the same answer as if you did parentheses -9 parentheses to the third power. But when we go to dividing exponents, it's going to make a difference. All right, so wait, let's pause here on this one. What this really means is -9 times -9 times -9. Why is our answer a negative answer? It's a negative number. Yep. Okay, so if it was -9 to the second power, would this be a negative answer? If this 3 was at 2 and it was -9 to the second power, it would just be -9 times -9. That's going to give you a positive 81, right? Two negatives. A negative times a negative makes a positive. Remember?
You said a -9 plus a +2.
No, a -9 raised to the +2. If this was a 2 instead of a 3, that's what I'm saying.
Does it matter if it's 2 or 3? If it's a +2, it doesn't matter, does it?
It does matter because you just need to make, if you do it in your calculator, it's going to give you the right answer. I just want you to make sure that you know the reason that this answer is negative is because it's an odd number of numbers that you're multiplying by.
So if it's a 4, it's going to be a positive.
That's right. If it's an even number exponent, then you're going to have a positive answer.
Okay, but what if it's a -4?
We're going to see about that later. Don't worry about negative exponents yet. I don't want to confuse anybody. Okay, so let's do number, I guess it's number 4. Okay, so put this in exactly how you see it in the calculator, on the paper. 2 divided by 3, parenthesis, raised to the third power. You get a decimal, a really long one. We're going to, we're just going to round it to the nearest tenth. So that's 2 numbers. So it's really going to be 0.330 if you want to be specific. I'm sorry. Don't look at other people as you can't trust them sometimes. Do it yourself. Okay, so now that we kind of know what an exponent is, right? Let's talk about the first rule, the first law of exponents, what we call them in math. Remember, laws, just like in science, laws are 100% proven. They're not theories, they're laws. The first law that we're going to talk about is called the product of powers. Okay, remember the powers are the exponents themselves. I'm going to circle the powers in this first example. And I'm going to show you what happens, what the product of powers tells us is what you do when you multiply exponents, okay? Let's write it out in expanded form first. So this 3 to the second is literally just this, 3 times 3. And that's multiplied by 3 to the 5th. So we have 3 times 3, 5 3s. So how many total 3s are we multiplying by one another? 7, okay? So isn't that the same as this? Right? If you were to write that out, you would write this out. So what did we just do with our exponents? Yes, we combined them, we added them. You add your exponents, write this down. When you multiply with the same base. All right. So if the base is the same, the big number, which all of these are on the first page, so you don't have to really worry about that. And you're multiplying, which there's a multiplication sign on all of these problems. That's what the product of powers is. It's multiplying we add the exponent numbers to get our answer. So let's just write this out expanded form. 2 times, and then 6 2s. Okay, so how many total 2s do we get? 7 total 2s.
Where do you see? There's another number.
Okay, so I'm going to tell you something that's very basic, but a lot of people get tripped up on this because they are working too fast. Remember I told you when you're multiplying, you just add the exponents to get your answer? So a lot of people will see 2 and then 2 to the 6, and they'll say, oh, 0 plus 6 is 6, 2 to the 6th. That's not the answer. Because this 2 here by itself is really 2 to the first power. We just don't write that because that's weird. We'd be writing an exponent of 1 on every number that was whole. But really, that's what that is. Because 2 to the 0 power is not 2. Let me show you. 2 to the 0 power is 1. It's a weird thing about exponents. You're going to learn that later. Okay? So this is 2 to the first power. So if you don't have an exponent in, I want you to write the number in so you make sure that you have it. So 1 plus 6 is 7. 2 to the 7th power. All right, so just because the base is not a number does not mean that we don't follow the same rules. What do you think we do with this last one, the x's? What do y'all think we do? It's multiplying. The bases are the same. They're both x. So what does anybody want to guess what they think the answer might be? X to the 13. Yes, because really what you have here is you have 5 x's. They're all multiplied by each other times 8 x's. So that's really just 13 total x's. X to the 13. You're adding the 5 and the 8. Okay. So let's go over what that rule is one more time. If you have any number, we'll just call it A, and the bases are the same, like here, you have 2 A's, they're the same base. And then any number exponent, like an M or an N, which could be a 5 or a 4, could be a 2 or a 3, whatever. You add the exponents together to get your answer. So your answer becomes A. And in this case, we can't add M and N and get something else. So we just say I just want you to know that you add those numbers together. You add those together. That's the rule. If you're multiplying, you add your exponents together. All right, so on these, what would we do on A? What would our base be, our answer? 2 to the 14th. How'd you get that, Chandler? You added the exponents. 6 plus 8 equals 14. Is everybody with me? Caleb, were you with me? Okay. Look at B. It's the same thing. It's just a negative base. And remember, put that little 1 in here so that you don't forget to add that 1 when you add your exponents. So our base is -7. Let's go ahead and put parentheses around it just because they do, and it's going to help us in the future. Add your exponents. So what is your exponent answer? -7 to the 9th. 3 plus 1 plus 5. 3 plus 1 plus 5 equals 9. Graham, you good? Okay. Look at C. Now, this one looks a little tricky first because this M doesn't have a parenthesis around it. But really what this parentheses are telling us is they're just being multiplied together. Okay, that's one way to note multiplication. So What you have really here is m, and then 5 m's, and then 6 m's. So that's 1 m plus 5 m plus 6 m's. 1 plus 5 plus 6 is 12, right? So our answer is m to the 12th. Keep your base the same. Make sure you know it's not 12m. It's m to the 12th. All right. I want you guys to try and do the bottom. And do not look up here until you're done with all three. And then check and see if you got the same thing I did. You should not need a calculator for this part. Don't look up here and just copy what I'm doing. In fact, I think I'm going to hide it. Okay. Check and see if you got the same things I did.
What does that middle one say?
-2 to the 8th power. Really important, guys. I know this seems very basic, so you have this desire to want to check out and do something else because you're like, oh, this is easy. I know how to do this. But please stay with me. This is rule number 1 of 4 when we're talking about exponents. All right. Now, we're going to go to page 2. Does anybody have any questions? Let's go to page 2. Let's look at law number 2.
I didn't get the last
What was the last one, guys?
one.
W to the 13th.
I'm going like F.
W to the 13th. You just add your exponents. 8 plus 3 plus 2. Okay. All right, I need everybody on page 2, the very top. We're looking at the second rule, which is power of a power. Okay? Power of a power. So let's look at that. So kind of figure this out. We're going to put this in expanded form first, like we did with the others. Let's do that. Let's write it out. So really what you're doing here is you're saying 5 to the second times itself 3 times. Write that out. 5 to the second times 5 to the second times 5 to the second. This is where it can get confusing, so make sure you're paying attention. Because look at this example. We have an exponent raised to another exponent. We call this a power to a power. All right? Power to a power. Power of a power. So what you're really doing there is the rule says when you have a power raised to another power, you multiply your exponents. All right? You multiply. So go ahead and down here and go down to rule. You multiply your exponents. So 2 times 2, or 2 plus 2 plus 2 would be the same thing as 2 times 3. What is 2 times 3? Yes, thank you. Yay, we can do basic math. So that answer is 5 to the 6th. You multiply. So write this at the top. When you have a power raised to another power, you multiply your exponents. Okay, when you have power raised to another power, you multiply your exponents. All right, so let's look at this next example. Let's write it out first. 8 to the 5th to the second power would be 8 to the 5th times 8 to the 5th. That's the expanded form. What is it in exponential form? Who wants to take a guess? Yes, 8 to the 10th. How'd you get 10? Yes, he multiplied 5 times 2 because he saw that the power was raised to another power. When we have a power raised to another power, you multiply the exponents. 8 to the 10th. Okay. Last example, and then we'll try a few more. X to the 3rd to the 4th power. So really that means you have 4x to the 3rd multiplied by one another. So it's a power to a power, so you multiply those exponents. So what's our answer? X to the 12th. Okay. So we've learned two rules. When the exponents are just multiplied by one another, like x to the 2nd times x to the 3rd, you add your exponents. But if the power is raised to another power, you multiply your exponents. So let's do that right here. Our base is going to be 7, the same. 4 times 9, this is a power to a power, gives us a 36. Okay. 17 times 2 is, yep. All right. Ooh, that's a big one. C. W to the 2000. That's cool. All right. I want you guys to do, well, let's do the rest of, let's do D, E, and F right quick. Okay, so this is where you might need your calculator, because you might need to do some multiplying. I mean, you might know what 4 halves would equal. It equals 2, okay? But you're doing x to the 4th. You're doing 4 times 1/2, okay? That's what you're doing, 4 times 1/2. So you can do that on your calculator. 4 times 0.5 is 2. That's your answer. The same thing with fractions. You just multiply them. 24 times 1/4. 24, you could do it times 0.25, or you could say times 1 divided by 4. That's a 6. So it's F to the 6th. What would be the last one? A to the, yes, A to the 4th. Because 12 times 1/3 is 4. All right, so now at the bottom here, I want everybody to try to do the bottom on their own. I'm going to, I'm going to cover my answers up, and then I'll reveal them, and you can see if you got the same thing. You might have to use your calculator to do some math. That's fine. I'm doing the same thing. Remember, power to a power, you just multiply those numbers.
So 5/18, right?
Yep. 5 to the 18th. Yes. Over 18 would be a fraction.
What?
Nothing. No, I said make sure you say it correctly. 5 to the 18th, not 5 over 18th. You know what I mean?
it can be like G 1 to 4.
Mm-hmm. Okay, so we have an acronym we use. Oh, check yours. And the last thing I wanted to teach you is this acronym. You guys remember this sheet that I said you could use on every test, and then you could use it on your star, right? We've done some of these things. We've done Dixie Roy D. We've done Stat Calc. We've done Hoy and Bucks. We've done Slope Dude, Slope. We haven't done FOIL yet. We've done the table down here. We of course know what PennBus is. So this P-man deals with exponent rules. P-man is an acronym that we use to remember our exponent rules. So let me show you what we have learned so far. Okay, on the side of your paper, I want you to write P-M-A-N. P-M-A-N. P-man. Okay, I know it's weird, but it's the only thing we can think of. All right. So here's what P-man helps us remember. P stands for power to power. So power multiplied to a power. If you have a power multiplied to a power, you multiply your exponents. Power to a power, multiply your exponents. And if you have exponents that are multiplied, I mean, if you see multiplication happening with our rule 1 we did, you add your exponents. So we've already learned the P, the M, and the A, and then tomorrow we'll talk about the N. And actually, we put N, D, S on ours. P-man DS, like a Nintendo DS. That's what I think of. So power to power, you multiply. If you're multiplying, you add them. Okay? So that's it for today. Tomorrow we are going to conclude 6.1 with learning rules 3, which is quotient of power, and 4, which is investigating the zero and negative exponents like y'all talked about earlier. So that's it for today.